Hello all, I'm Siddharth Kaul and I welcome you to Edupedia World. In this video, we are going to revisit scripts in MATLAB. Here we will see how to create scripts, how to add comments, and how to independently run code sections in the scripts. So what are scripts? Scripts are the simplest kind of program files because they have no input or output argument. They are useful for automating series of MATLAB commands such as computation that we need to perform repeatedly from command line or series of commands that we have to refer.
Something that we have already seen. So I'm just going to revisit it very quickly. So there are two ways which we can create a script. Either we go to file new script or we can just click a new script button. So just I'm going to paste some few lines and I'm going to save the script. I will save it as say demo script underscore 2 as.m file. I will replace it, and then to run the script I will just go to debug, run demo script 2, or I will click F5. So there error is there. Okay, so histogram function. Now I'm again going to go debug, run. So what is this supposed to do? Is this supposed to plot a histogram of some random data? So a histogram has been formed. So this is how we can create a new script. We can type it our own, and this time we already know that using percent where in a MATLAB script file or in a function file. So here I'm going to add a comment like this is a comment. So basically this is a comment. So what else we can do is we can have a multiple line. We can comment multiple lines by using a shortcut that is Control plus R, or by just right clicking and then selecting the comment. So this will comment both the selected lines. We can similarly uncomment this by clicking Control T, or we can right click and then select uncomment. Other than that, there is a cell break options that divides the code into different sections. So that is denoted by a double percentage that creates a cell block. So this is a cell block. So what these cell blocks do is basically the cell blocks divides a script into smaller subparts. So what happens is this smaller subfile can be either folded or can be evaluated separately. So in case we have very long scripts or something like that, we can break it down into smaller subparts and then evaluate each of its subpart independently. We will look into this independent evaluation after the so in this video about code. So let's explore that a little bit. So here you can see I have a sample code where I have created two sections where I calculate and plot the sine wave, and in the second section I modified the plot properties. So in the first section I have a vector x that is from 0 to 1 to 6 into pi, and we have y is equal to sine of x, and we are plotting this sine wave. So the aim is that I need to find this division factor in such a way that I get a very smooth kind of plot. So, and after I get a smooth kind of plot, and then and only then I will go and modify this plot properties. So what I will do is I will go to this calculate and plot sine wave section. I'm going to right click it, and then I'm going to evaluate the current cell. So you can see a plot is that MATLAB creates a plot for me. So as you can see, there are some this smoothness is not there. It's like straight lines are there, number of points are less. So let's fix that. So what I'm going to do is I'm going to select this one. This one is basically the spacing thing. So we have from 0 to 6 pi, and 1 is the spacing between them. So what I'm going to do is, you should observe carefully, observe the graph carefully. What I'm going to do is I'm going to go and click divide. So as I go on dividing, the spacing reduces from 1 to 0.5 and the curve gets a little bit smoother. I'm going to divide it further. So again you can see the spacing has reduced to 0.25 and the curve has even smoothed down. I will click it one more time, and again one more time. Okay, let's do one more time. So now it's like something smooth. So now what I'm going to do is I'm going to go to modify plot properties, and I'm going to evaluate this section. So as you can see that all the title, the x-axis and the y-axis label gets updated. So this is how we manipulate this different sections of code inside a MATLAB script file. Program files can be one of the two things. It can be a script file that simply executes a series of MATLAB statements, or they can be functions that also accept input arguments and they produce certain kind of output. Both scripts and function contains MATLAB code, and both are stored in text files with a .m extension. However, functions are more flexible and are more easily extensible. For example, to create a script in a file named tryarea.m that computes the area of a triangle, the script code is shown on the left side. So we take a variable b, we assign it some value of 5, we take h, we assign it value 3, and then we compute the area. We call this script file after we save this file, we call this script file from the command line by typing the script name, that is tryarea. So it automatically computes the area and gives returns as 7.5. Now to calculate the area of another triangle using the same script, we have to update the values of b and h in the script and rerun it. So each time when we want to change the input, we have to go into the script and change the variable value and then rerun the script. So you can see that this becomes a manual updation and it takes a lot of time. So the simpler way to do this would be to create a function and replace the in this function we will replace this b and h assignment statement with a function declaration, and where we take b and h as an input to this function. The declaration includes the function keyword, the names of the input, that is b and h, and the output argument, that is the area, that is a, and also the name of the function. So we write something like this: function a is the output, which is equal to tryarea bh. Tryarea is the name of the function and b and h are the input for base and height. Now we compute the area by a is equal to 0.5 into half into b into h. So after we save this file, we can call this function with different base and height values. So from command line, without modifying the script, we can just call the tryarea functions 3 times and get 3 different areas. Say in a1 we passed values of base and height as 1 and 5. In a2 we passed as 2 and 10. In a3 we passed as 3 and 6, and for all 3 we get different values like 2.5, 10 and 9 respectively. Functions have their own workspaces that is separate from the base workspace. Therefore, none of the calls to the function tryarea overwrites the value of a in the base workspace. Instead, the function assigns the result to the variables a1, a2 and a3. This concludes this video on scripts. In the next video, we are going to take a very detailed look into functions. So until then, please subscribe and thanks for watching.